Please confirm if you can see my screen. All right. Good GM everyone. Good day from wherever we are. Um, you're joining from. How is the day going? Um, so we'll just dive right into it. Welcome to the Tokenbound workshop, and today we'll be taking a look at the SDK and a brief at also the Connectkit. So in the last workshop conducted last week, we saw how you can integrate the SDK into, saw how you can integrate Tokenbound into your contract. Um, I don't know if I have to like go over that, but then to follow along with this workshop, you can easily like go to the Tokenbound V3 workshop. So you have the contract present in this folder, the SRC, and then you have the SDK present here, like the example we're going to do today. So basically, today's workshop will be a walkthrough of setting up a token-bound instance and also like utilizing the methods. So we know for a fact that token bound is basically you transform your NFT from a digital asset on chain into a smart account. And I believe we can remember that you have the account component and also you have the registry component. So the registry allows you to transform your NFT into a smart account using the account interface. So the SDK is just an abstraction for of that, right? Such that you can use that both at the front end level and also at like the back end level. So to get started, how do I know if anybody has questions? I didn't ask. Um, do I join chat? Sorry, give me a minute. Let me confirm something. Okay. All right then. So to get started, we need to install the SDK. My preferred package manager is Yarn, so I'll just like set up with Yarn. Um, so before we even install, let me just show us what we'll be working with today. Let's start. Um, All right, so this is what we'll be working in today. Basically, connection with either your agent or Bravo's wallet, and also um, looking at the individual methods in the SDK. You have the deploy, you have the execute, and then you have send ERC20, you have send NFT, you have the lock to lock the account. Basically, when you are on a marketplace or you want to like trade your NFT, this is just like a safety measure. And then to upgrade your account from if there were to be like a new implementation, and then to set permissions to have addresses perform actions on behalf of your account. So we'd be seeing like this method and how you can easily like implement them. But for starters, we have to like have the SDK installed. as a dependency in our project. So split my screen. So to basically like touch on something real fast, this is the Explorer, and what we are doing here is basically give me a minute. Don't know why. Yeah. So as you can see here, I'm getting a list of all the NFTs I have, and what we are going to do in this workshop is just pick one of that NFT, right, and have it deployed, get the status, get like informations about it, and execute actions based on that. So I'll go to stock scan. Let me check stock scan and get. Just get this. So I'll copy the contract address and I'll paste the contract address here and also the token ID. Uh, mhm. CTO SDK. Oh shit. CTO SDK. Yes. Where am I? CTO. Okay. Yeah, so this is the SDK has been installed. All right. So let's take a look at the documentation. So we're done with the installation. So we need to like configure our get the instance. So we have the Tokenbound client, we have the TBA version, and then the TBA chain ID. So basically, when you want to instantiate the Tokenbound instance, you need to pass in the account. So if you're integrating with a UI, you basically know that all authentication of transactions are done by your wallet, right? You need, and most front end, all front ends basically integrate wallets to sign transactions. So you need the account object here, and then you need to specify the versions. So why you need to specify the versions here is because previously we had V2, and currently we made some update, and then we have V3. So to enable backward compatibility, right, we had to like introduce versioning. So if you prefer working with the V2 contract, you can revert to the V2 contract. If you prefer working with the V3 contract, you can revert to you can use the V3 contract. So you can either specify either V2 TBA version V2 or V3 here, and also to configure the chain which you want to reference that your action on. You can either choose between testnet or mainnet. Then this just in our process is just like an entry to the node to make a request to the blockchain. Then this sort of like generates your instance for you. But here, what we have is we have a state to manage our token bound on line 36. So basically, I'll comment out this and Yeah, so we have the Tokenbound instance here. This current implementation is on mainnet. Mainnet is quite cheap, so I prefer to like use mainnet. So please, if anybody has question, please let me know. I can get to that in the comment section, right? Or is it private chat? All right. So moving on. So, and if you were to like want to integrate at the node level, say your backend, we know that for every transaction you want to sign, basically the core mechanism is you're using your private key. So another approach would be to like just reference your private key here and then pass in your private key, but then it's not advisable to paste in your plain private key. Just use what is it called? Use in a an environment variable, right? So it keeps your private key private, so you don't push your key to production. So basically, but then this is just for front end integration. So if it were to be like a back end integration, you would have to like replace this account with your private key. So looking at the methods we have available, we know that you can create an account, and create account basically um, turns your NFT into a what was it called? Into a smart account, and expects you to pass in the token contract, the token ID, the salt. I have to have updated this documentation. Sorry, give me a minute, please. Docs. Um, yeah, sorry for the delay. I had to resolve something. Um, yeah. So you pass in the account, the TBA version, and you can reference. So we didn't have a section on this documentation. So when you configure your instance, you can also like create your custom account and also your custom registry. So we sort of like give you the flexibility to be able to like reference your implementation address here and also registry address. So um, what I mean is that you can pass in your implementation address here, and you can pass in your registry address here. But by default, if I don't specify this, right, which automatically picks the already deployed contract from the SDK, that is how we sort of like customize it. So if you were to like have your own custom um, token-bound account interface, perhaps you need to like add, extend the logic and something like that, or you need to extend the logic of your registry. Then the deployed address on either mainnet or testnet can be added here, right? Then you are good to go. But without adding this, we sort of like reference the already existed deployed contract uh, on the network. I don't know if I can sort of like show us what I mean by that. So sorry, this is not a code review, but then I just need to like show like the idea behind it. Um, SDK. Shall I say? addresses. Yeah. So this is what I mean. So we have like by default configured all the addresses and the ABIs to be here. So for V2, you have the implementation address here, the account, and then you have the registry. For V3, you have the address here and also this. So without specifying implementation address or the registry address, the SDK automatically picks it up. So if you now have like a custom account or a custom registry that you extended, right, you can just pass in the address here and then specify additional details here. So moving on, so we have several methods, just as we have seen here. You can deploy your token bound, you can execute a transaction, send ERC20, send NFTs. Basically, every action you can basically perform with a normal account. So moving on, let's try and like deploy. So we just await. Since the function is an async function, token bound, no, token bound dot create account. Then the create account expects your token contract, which I have specified here, and then it expects your token ID and expects the salt. And what the salt does is, sorry, specify salt here. So salt can be any random value. So I'll just specify 2000 something here. So what the salt does, it sort of like randomizes the pre-computed address, because when you are transforming an NFT into a smart account, there has to be an equivalent address for that NFT, right? So it sort of like pre-computes your address for you, and this sort randomizes your address. So we have Tokenbound the create account, which expects your token contract, then the token ID, then the salt. Let's response because it's response is a dot with transaction. Let me just cancel the log. Transaction hash. Yeah. There's no need to like set transaction hash. Let's just say transaction hash here. Okay. Search. Transaction hash. Yeah. So we're done with this. So when you deploy, we also want to like get the details of the token bound account, get the deployment status, and sort of like get the class hash. So what we do is search for the method that does that. So get account, we have a method so that you can use the token bound to interact with. Okay, this get account basically gets the token bound address. So you still expect the token contract, the token ID, and then the sort. So always remember that when you want to like fetch the token bound address, the sort you used at deployment should be the one to be referenced when you are when you want to get the account, right? Because if the software to be different, it's going to point to another address. Remember, the source sort of like randomizes the address being generated. So under here, we have these methods that are sort of like fetch that fetch the account status, the account address, and also the deployment status. So in the account, the method remains the same. You have to use your await token bound dot get account, which is already here. Let's sort. Then we execute this one here. So let's go back. This is weird. Uh, Let me see. Okay. Yeah, we have the address here. Let me do log account. Address. So I'm just trying to like see the account being returned, then I'm trying to like format it here. X to string the account. Let's see. Zero six. Yeah, okay. You're getting the correct address. Yeah, so we have this address, and then we can easily check it on the stack scan to see the status of the account. So the account is yet to be deployed. Um, we see that it contains empty assets. So what we need to do is to deploy the account. But then before we deploy the account, I want to show another method, which is the check account deployment status. So this check account deployment status basically gives you like the status of your account, either it has been deployed or not. And currently, so this is how the method works. You expect the token contract, the token ID, and then the salt. So I'll just uncomment this and have this here. So you can see that it's more of like we passing the token contract here, the token ID. Then from here, specify, so this status, this check deployment account status returns to item in its object. Let me just log it so you can see. Status object. No. Status. Did I clean this console log? Let's go here. So it returns the class hash, and then it returns the deployed state, either it is true or false. So as you can see here, we have like the Tokenbound address, we have the deployed status, but then the class hash is yet to exist. So if I were to deploy this, if I were to deploy this now, it should pick it up. So let's try and deploy first and see if it's going to work. Okay. Okay, let's refresh this and try and copy. No. Time to pick up. Yeah, okay, I didn't connect my wallet. Um, Here shows this one has been deployed. Then I should pick this up. Uh, Sorry, give me a minute. Okay. Get accounts, token contracts. Log. Accounts. Oh, why does it now take time to load this stuff? Ah, okay. Now it has returned the address for us. So let's just copy and see. Let's just copy this and paste on stack scan. So it shows that this contract was deployed at around like 3:24 today. And if you check read and write section, you can see that you have the execute, the upgrade, the log, and then set permissions, and basically it contains like the interface for accounts. So moving on, let's get the owner address of this account. So we want to like get this address, this account, the TBA, who does the account belong to? So we have the method to fetch that here. And going back to the documentation, we've seen the get check account deployment status, and then the get owner. The get owner basically expects the tokenbound address to be able to like fetch the owner of the NFT, and then the owner of the account rather is the person that deployed the account. So since this address 0x that ends with D1B deployed the address, so it should be the address that will be referenced here. So execute it here. Get account owner and also get NFT owner. And another method we are to see here is so we have the get owner. Yeah, get the owner of the account, returns the address of the tokenbound owner, and this get owner NFT extracts information about the original NFT that is paired with the tokenbound. So basically returns the address of the owner of the NFT, rather. So and it expects the TBA address. So what is happening here is once you pass the TBA address, you sort of like set it to the state, then return that, then format the address to show like the um, formatted structure. So you can see the account owner here, which is this one. We can see that it correlates with what we have here 0x, 02f, 6, then hence with D1B. And the NFT contract owner basically references the contract address where that we supplied here, here. Yeah, so you can see that it tallies. So that is that about like creating the Tokenbound account, um, and then getting the owner. So to now see like the core functionalities of executing a transaction, sending an ERC20, they would go into the documentation section. Um,
So let's see transfer ERC20. The method should be somewhere here. So transfer ERC20. So to be able to transfer any asset, we have to sort of like ensure that the account has some token in it. And currently, if we check the balance right from here, the portfolio should be empty, no token balance. What we're going to do is we're going to like send some tokens to the account address. Is it 7 key? Yeah. So let me just send uh let's send one stock. 69. So if I should refresh this portfolio section, should reference the one stock here. Does it take that long to show? Yeah, so we have one stack here. So to transfer an ERC20, we are expecting the TB address, we are expecting the contract address, and also the recipient and the amount. So what we are going to do is let's talk about transfer ERC20. TBA address should be TBA account. Contract address. So the contract address would be the contract address of like the token we want to transfer. Let me check the address section here. Stock token. Yeah, I want to transfer stock token. Sorry. Sorry, just pardon me. I'll clean up the code when I want to like push. So token contract address. SST. CRK. And the recipient. So that will be the receiving address we want to like send the stuff to. Let's just send it back to this guy. Yes. Then last parameter, which is the amount, recipient should be recipient. Then amount. Let's just send what we have here. Okay. Options. Then we have transfer. Options. transfer. Mutual system activity. Let me just to the address. Contract address. Then SRP address. Recipient. All right. So we're done with this. Let's try and execute. So let's get this. Does anyone have any questions so far? Oh, where were we? Yeah, I wanted to try this one out. So, transaction results. It doesn't return any data. Oh shit. Okay, let's try and send. Let's see. Account unauthorized. Okay. Command address, TB address, this. This is this one. I should go TB address, contract address, the recipient, and then the amount. Okay, let's try again. Account unauthorized, reject. See, now with this account, why is it not unauthorized? Where it's wait. Do I have any console log here? I need to clean the logs.
Okay, let's try again. I don't know why this thing takes time to set up. Oh, oh, I was using my other account. Sorry, and I know why it wasn't being authorized. So should pick up the changes now. So I was trying to like sign the transaction with another account. So I was using this account. You should know that the account that was used to deploy the token band was this account. So um, just like a train of thought, like a simple explanation, when you just as we can see here, we have like all NFTs that an asset that an account, a normal account has here, right? And then we want to like turn, so we want to like turn this. I think I should have an already deployed one, just to like give us like a visual perspective of what we are doing. Then want to like turn this to a smart account. So once we deploy this one, it turns to a smart account. Then we want to like transfer. Let me just see. Let me deploy. But it's trying to give like a visual explanation of what I mean. So basically, what I mean in this sense is that you want to transfer one your asset from this account. So it's the parent account that sort of like authenticates that transaction. So in that previous case, I was trying to use another account. So obviously, the authorization is going to fail. But if I should head back here, I don't know why this hasn't picked up. Is there something wrong somewhere? Let me just load this. Mm, account. So we can see that it's this same address here as what we have here. So if I should execute this send ERC20 now, this execution should go. So when did I enable 2FA now? That's the same system life. 521356. Yeah, we can see that we're not getting that error again. So let's trace the transaction. Then back to this transaction successful. Then let's inspect the address of this person and see. So we can see that the balance increased, right? So similar thing if you have an NFT, this send DRC. Okay, let me see. The Explorer should be able to like give like a visual. Um, so I'm trying to like give Explorer so it's not like too abstract for us. Okay, let me deploy it. All right. So we can see that what I mean by asset here now is we have this ERC20 assets here. We have ETH, Stack, USDT. So what we did previously here in this send ERC20 was to send what's it called? Where's the method now? Was to send an ERC20 from our Tokenbound account to this recipient here, and then we were able to like confirm that the person was able to like see the funds. So
this collectible stands for your NFT assets, but presently we don't own any NFT asset. Might have to like start transferring NFT around, but then we don't have much time. So it works similar in the same manner where you have to like specify the Tokenbound address, just as we did here. Specify the contract address of the NFT asset, then the token ID, the recipient, the sender, right, and also like the recipient of that NFT. So you can easily like read from documentation what this each parameter means. So moving on, we have the execute method. So the execute method is like the entry point to make external calls with your account, with your TBA account. And it didn't pre-generate a payload like a selector. Do I have a contract? Um, okay, let's see. Let's see execute. Yeah. So we have this call type here that expects this structure, that expects your call structure to which contract are you trying to make a call, what selector are you trying to call. And we know that selector are basically like function identifiers that represent the function names to be called on a particular contract on the network. So the address and then the method to call. If you were to like specify an invalid selector, it's going to like reference that the method you're trying to call doesn't exist. So basically you want to make a call, right? Just give me a minute. Let me see if I can come up with something here. Let me see. Execute. Let me just copy this and I'll show us something. So I need this contract address. It is on mainnet or testnet. Let me try mainnet. It's on testnet. Okay. Increase amount. Do I have any contract on mainnet? Let me see. Deploy contract on mainnet. Okay. All right. Let's do something. Let's go back to this. We have this is our stack address. Here. Execute. Okay. So I just specify. So we want to like specify the call. So we have const call one call, which expects like a call interface, and we have
a tool. Want to make a call to this address and a selector. Let's say a selector, and then a call data. Call data, which is an array. So this is here as a 20. This is stack token on Stacknet. So what I want to do now is I didn't provide an address beforehand. Let's see if I can if I'm able to call. So yeah, so I want to call this transfer method on this account, and then I'll specify the amount. So I am going to like copy the equivalent amount that we have here as the call data, and utils. So to generate function selectors on Stacknet, right? We know that function selectors are basically how you're able to like identify a function on a contract. And in Solidity, you know that to get a selector, you need the function name, and then you need like the data type of like the parameters it's expecting. But then for Stacknet, function overloading is not allowed. So you just need to like get like a selector of the function name only, which is this selector here. That's what I'm going to pass through here. And so let's try, this should be outside. So await tokenbound dot execute. Then we are going to reference the TB account. TB account as string. Then the call here. So let's see if the execution is going to go. So if you have multiple contracts you want to call, so you just like specify the contract you want to make the call to, the call data, and something like that. So in a nutshell, what we're trying to do here is we're trying to like make a call to the will this work? It should, yeah. We're trying to make a call to this SRK contracts for it to transfer a certain amount. So we need the amount and then the recipient here. So who are we sending to? Let's send to this guy. So this is the other core data. I think. Yes. So let's try and execute and see if it's going to work. Execute transaction. Failed to deserialize parameter 2. Is this gives can be plain, it should be a string. Let me just do Tokenbound. Then transfer expects the recipient and then the amount. Recipient, then the amount.
Okay, let me see. Just gonna include that too long. What? It's not easiest to just format this directly. I didn't even need to do any formatting. If you to just add this parameter to, is this the correct selector? So here, yes, yes. Data, then this. Should take this reference parameter to. Do not really expecting just one parameter to execute. Execute. So this reference parameter to. Okay. Oh, that's weird. That's weird. I think I'll come back and like resolve this error. Is there another method that expects like a single notice transfer from expect three parameters? Okay. I don't want to like waste much time, but basically this execute is like the entry point to like make external calls to any contract, and then you can have like multiple calls and multiple contracts within this stuff. So another method is the lock. The lock is basically to keep your assets secured, and the method that does that is predefined here. So we want to like firstly get the status of if your account is locked, and let's also see like set permissions. Get locked status. I think we are far behind ahead of time. So to lock now, lock. So the lock expects let's see, await tokenbound dot lock,
and it expects your TBA account. Your account, and then log onto. So to specify should be a number. Let's use one here. So to specify the time you want to like lock it for, it's always advisable to like use the approach time converter. So it gives you like the correct time. So what we're going to do is not Unix time. Approach time converter. Oh yeah. So this is like a how do I describe this now? An approach time converter gives you like the current time in milliseconds and stuff like that. So what I'm going to do here is, so this is the current uh, convert. Mandate. So this is the current time. So 16:03. No. Is it GMT use? Is this local time? Okay. Let's do this. Let's do 03, 10, 06. Then we're going to copy this. Quickly have it pasted here. Save. Then let's try unlock. So this is reference. Let's come back to this one. So this account is currently locked. We can't perform any action on it. Let's see for how long it's locked for. Oh. So this is locked for 84 seconds. So you can't perform any action on it now. So the use case of this is basically for marketplaces. If you were to like list your Tokenbound for sale, right? So in order to ensure that it's secured while like trying to like trade with the second party, so you sort of like lock your account, and then when you sort of like receive your funds, then you're able to like release that the the assets. So this upgrade basically is simple. Now we are working with the V3 contract, so there's no need to like see the upgrade. But then what the upgrade does is, if you were eventually to like make some changes to um, the V3 we have now, say V4, right? You have to like upgrade your account, and everything still basically remains the same. You have the same amount of token you have in your
talking about address, the address remains the same, nothing changes. So, but then you're just upgrading your implementation um, to support the latest version. So you're going to like specify the class hash to upgrade to, and then the Tokenbound address. And basically, we know that class hashes are like when you declare a contract, which means you're like registering the blueprint onto the network for Starknet specifically now, that means you're able to like create multiple instances of it, right? So you specify the class hash here, and then from the class hash, you're able to like upgrade to your new account to the latest version. So for set permissions, it allows you to assign or revoke specific permissions for different addresses on Tokenbound accounts. So if you want to like give permissions to different accounts to maybe perform actions on your behalf, then you can do that with this set permissions. And how that works is basically that where is set permissions? This should not be here. Yeah. So set permissions respects await Tokenbound dot set permissions. Set permissions expects the TB address, which is a TB account, expects permission addresses. So this permission addresses is an array of addresses you want to like give permission to, and then the state of what you want to do. Either you want to, so if we were to like have 0x1 here, say 0x2, they are equivalent of their respective sorry, this is a string. To the respective state you want to like the respective row you want to give them. So it's either you set this to true, false, depending on what you want to do. So I would add two addresses here to like give them permission. Let's see, set permission address. Just set permission for this one. Account. Yeah. So if I should go back here, then I execute set permission, should be able to sign the transaction. And the current status says false. We can see that the locked time is due already. So if I should refresh, this use effect that doesn't pick this thing up as soon as possible. Um, oh, this is funny. Yeah, so you can see that set permission is true now. So these are like the methods. We didn't try out the send NFT. Ideally, I should have sent an NFT to the address we created, but then from the documentation, you can easily like reference and see the walk through. So for the Connect Kit, so the Connect Kit provides a way for you to be able to like interact with external dApps for your with your token bound and um, test. This was
So just like a little recap on what we have done, right? We installed the SDK and we sort of like did the setup right from here, customizing the parameters, the account, the TBA version, um, the network in which you want to like deploy the TBA on, and also the token contract you want to deploy, the token ID, and sort of like created the account. From creating the account, we saw how to send assets from your token bound, and then we saw how you can lock your account and a brief of the execute transaction. I think I'm passing the wrong parameters here. I'm not like formatting data correctly. That's why I'm getting the feed to deserialize parameter two. Um, this upgrade, it helps us to like upgrade our contracts from if we are to have a new version, the upgrade method will be the one to call to upgrade to the latest version. Then this set permissions gives you the right to delegate role or like give privileges to certain addresses. Now, so what exactly is Connectkit? Now we know that the fundamental thing is that you have your token bound from an NFT, which in this case would call um, non-interactive. Let's use the word non-interactive or cannot. Let me just use the word dumb, for instance. Yeah, please don't mind my wordings, right? Then using like via the snip, right? Your token bound was transformed from your NFT, which has an address. No, it has no address. It's just an asset. It's transformed to a smart account. Let's call it the token bound account. Token bound account, right? And then we know that what are like the functionalities of an account. An account can execute. Let me see functionalities of an account. Account. An account can should like be able to like remember this from our like introduction to Ethereum. An account can hold an account um, can hold um, can hold assets, i.e. fungible and non-fungible. I can't spell assets, right? An account contains code, contains forget so on Starknet we have just one kind of account, unlike Ethereum that we have like EOAs and what have you, EOAs and then smart account. But here we have just all accounts, and those are accounts can contain like logic, so contain code, and then we know for a fact that they are able to like they contain a storage, right? And then they can hold balances. Oh, cannot assets code. Then yeah, make perform execution. So now we've transformed your an asset from a dump NFT to a smart account. So similar, we should be able to like, use these accounts, right, to perform actions such as maybe swap on have known, or maybe like interact with Starknet ID or any external DApp. So how are we able to like achieve this? How are we able to do this? We'll not be able to like go into the code. I think we are far ahead of the time. So I'll just like give a simple example. So that is what Connectkit does. And what it does is basically that remember that from here, just to like create a visual perspective to it. From here, we fetch all the NFT asset here, right? That is tied to this address, correct? And this address is contained where in our agent wallet, right? And if I am to copy the
So going back to our example, right, we have our return address here, the tokenbound address, right? And then we can see that the owner account here is this one, and then the wallet reference here is the agent wallet, right? So if you want to like make, say this, for instance, that this example DApp were to be an external DApp like have noon, right? And then we want to like connect our wallet. Ideally, what you're going to see is like a list of wallets, right? So you should probably see like Connectkit as one of the options. So if you click on wallets here and then you specify your token bound address. Now, what this parent wallet account means is what wallet deployed the token bound, right? And from the example we've done so far, it is not Bravos, it is not Agent Web Wallet, it is not Controller, it is the Agent Hex, right? So if we should connect with this, should be able to like connect. So we can see that the address is connected, and then we're able to like make um execution just like a normal account, right? And sign transactions, right? That is like the simple idea of the connect kit. So as time goes by, as we see more products sort of like try this out, you can easily like integrate. Let me see. So say I go to Havno, for instance, and I am to start trading. So if you're to connect here, you can see a list of like wallets. So the idea would be you'll see the connect kit here, and then when you see connect kit here, reference of connect kit, it's going to like follow this model where you're going to like paste in your address and then select the parent address then connect. So now for if you were to be on Avnet to directly be connected to this platform, then you can make transactions and what have you using like the connect kit. But currently we're still like looking at the possibility of that. And yeah, that is it. So just to like look through like the code of the connect kit. Um, So if you're to like use the connect kit in your project, just basically like import this existing method supplied to you, the connect, disconnect, and then the token bound, the TBA startnet window object. And you sort of like set up your account, yeah, your connection here. It returns a wallet object that contains like the account and then the account addresses. Then you specify the network in which you want to connect to. Is it like the test network or the mainnet network? Then do you have your method specified, then you can start like executing transactions. But then a more clear and distinct example can be found on the repository here. I would clean up the code here and make a reference and a link to it. But let me just show us what I mean by that. Connect kits, yeah. So so you can see that you import the disconnect and then this disconnect method, right? And then it's instantiating the method is using this. You pass in like the chain ID and then the policy. I think this is cartridge. Passing these parameters, and basically you're able to like make transactions, like execute transactions using the connect kit. But then you can find more details on about that on this section or if you have any problem during development, just reach out to me. I'll see how we can resolve that. And one other thing, uh, yeah, it's about iframes, marketplaces. Like you can also integrate this on your DApp, so it gives you like details of assets and details of a tokenbound and the asset it contains. Um, Moderator, please, do we have any questions? Any question from anybody? I think we are like 22 minutes beyond like the specified time. All right. So if anyone has any questions as to like setting up or you encounter a blocker, please don't hesitate to reach out, and we'll always like be available to take your questions and also resolve your issues. So the and also just to like see an idea of what can be built with Tokenbound, we have like a section on the Explorer where we where which contains like project showcase. Um, yeah, showcase. Yes, so we did an hackathon earlier this year that contains like the category of projects such as NFT marketplaces, games, social um, um, projects, social that featured for a social project, and also how I think CrowdPass, a decentralized event management. So you can take a look at this and see the project idea you can incorporate your Tokenbound with. But basically, it's centered around gamings, marketplaces, social dApps, and yeah, gaming is basically. I think that would be all from my end. In the absence of questions, again, that will be the end of it. And also, in case you don't have questions now, if you have questions later, you can just come to the Explorer and join our community. We have the Telegram community, open Telegram. You can see. I'm trying to like bring this screen here. Yeah. So you can join the Telegram community, ask your questions, whatever you have, any block or anything like that. The team would always be open to like resolve your issues. Yeah. So thank you for joining the workshop. It's been nice walking you through Tokenbound and sharing with you this exciting project we've been working on. And look forward to seeing us try it out. Onisu.